So in this video, we're going to talk about radical equations. So square root equations are example of radical equations. So when we say radical equation, it is an equation that contains a variable in a radical. Like for example, cube root of x equals to the square root of x plus 1 equals 4. Then the square root of x equals 2, and the square root of 2x minus the square root of x minus 1 equals 0. So are examples of radical equations. So to solve the square root equations, apply the squaring property. So when we say squaring property, so squaring property, if two expressions are equal, then their squares are also equal in symbol. If a is equal to b, then a squared is equal to b squared. So to illustrate, consider that the square root of x is equal to 3. So to solve this equation, square both sides of the equation. So we have a square root of x is equal to 3. Then apply the squaring property by squaring both sides of the equation. Then simplify, cancel the radicand and the exponent. Then copy inside the radical, which is x is equal to, then simplify the square root of 3 is 9. So that's the correct answer. Another, try to solve this. Square root of x minus 9 is equal to 4. Again, apply the squaring property. So the square root of x minus 9 is equal to 4. Then square both sides. Then cancel the radicand and the exponent. Then copy the radical and the exponent. Then copy inside the radical, which is x minus 9 is equal to the square root of 4 is 16. So to solve for x, apply the subtraction property of, apply the addition property of equality. So x minus 9, then add both sides by 9. So plus 9, then plus 9. So x, cancel this. So 16 plus 9 is 25. So the squaring property can be extended to any positive integer n. So if our a is equal to b, then a raised to n is equal to b raised to n. So use the concept with the fact that, okay, the nth root of a raised to n is equal to a. So let's have an example. The cube root of x is equal to 4. So to solve the equation, raise both sides to 3. So the cube root of x is equal to 4. Then raise both sides by 3. So cancel. Then x is equal to, so 4 cube is equal to 64. Therefore, our x is equal to 64. So there are steps in solving radical equations in the nth root. First step, isolate the radicals. Second step, raise both sides to the nth power. Third step, solve the indicated variable. And fourth step, check the answer. So to illustrate, let's try to solve this using the steps in solving radical equations in the nth root. Cube root of x plus 1 is equal, minus 2 is equal to 0. Okay, first step, isolate the radicals. So the cube root of x plus 1, then transpose this on the other side, so is equal to positive 2. Second, raise both sides to the nth power. Since our power is 3, or our radical is cube root, so we raised it both sides by cube. So to cancel this, cancel. So x plus 1 is equal to, so the cube root of 2 is 8. Then simplify. So x, transpose this one on the other side, so is equal to 8 minus 1. Therefore, our x is equal to 7. So by checking, how you are going to check that? Okay, so the cube root of, since our x is 7, so apply the substitution method. So 7 plus 1 minus 2 is equal to 0. Let's try to check if it is true. So the cube root of 7, or 7 plus 1 is 8. Then minus 2 is equal to 0. Next, so the cube root of 8 is 2. Minus 2 is equal to 0. Then 2 minus 2 is 0, which is equal to 0. Therefore, it is correct. So some solutions do not satisfy the given radical equation. So this is called the extraneous solutions. Okay, like for example, consider that we have the x plus 5 is equal to x. So isolate the radical. So we already done isolate the radical. Then square both sides of the equation. So apply the squaring property. So cancel, cancel. X plus 5 is equal to x squared. Next, simplify. So equate it by 0. So x squared minus x minus 5 is equal to 0. Okay, let's say it is 4x. Okay, then after that, apply the factoring. So x minus 5, then x plus 1 is equal to 0. So our x is equal to 5 and our x is equal to negative 1. Again, x is equal to 5 and the other x is equal to 1. So that's the value of our x. So let's now check the solution. So the square root of 4x plus 5 is equal to 5. Now the square root of 4 times 5 plus 5 is equal to 5. Let's try to prove if they are correct. Next, the square root of 20 plus 5 is equal to 5. So the square root of 25 is equal to 5. Then the square root of 25 is 5 is equal to 5. Therefore, it is correct. Next, how about this one? Let's try to check this. So the square root of 4x plus 5 is equal to 5. Negative 1 rather. Okay, so the square root of 4 times negative 1 plus 5 is equal to negative 1. Next, 4 times negative 1 is the square root of negative 4 plus 5 is equal to the negative 1. Then 4 plus 5 is the square root of 1 is equal to negative 1. So the square root of 1 is not equal to negative 1. So after checking, we can say that x equal to negative 1 is an extraneous solution because x is equal to 5 is the only solution. Okay, so that's how to solve radical equations.